Welcome. In this session, we are going to see how to find inverse Laplace transforms using convolution theorem. So let's project an example and see. So the example here is that we are supposed to find the inverse Laplace transform of these two functions using convolution theorem. So the key thing is that we need to apply convolution theorem for us to state or to give inverse Laplace transforms of these two functions. So our solution, the first thing, let solution for A let us take capital F of S to be the same as 1 over S plus 2 and G of S be given by 1 over S plus 3. So remember, we are remembering that convolution theorem states that the inverse Laplace transform of product of two Laplace transforms, F and G, is given by convolution of the function F and G. So this is the aspect that you want to apply. I remember this can be written as 1 over S plus 2 times 1 over S plus 3. So this is what you are calling capital F of S. This one is what you are calling capital G of S. So therefore, now with this, we write, then we also know that F of T will be given by inverse Laplace transform of capital F of S, which in this case, using the tables of Laplace transforms, you find that the inverse Laplace transform of this function 1 over S plus 2 is e raised power minus 2t, and G of T is the inverse Laplace transform of capital G of S, which will be given by, using tables of Laplace transforms, you know that this is be given by e raised power minus 3t. Now, the inverse Laplace transform of the function given, which is 1 over S plus 2, S plus 3, is the same as taking the inverse Laplace transform of 1 over S plus 2 multiplied by 1 over S plus 3. Remember, these and these are the same expressions. And so these are the same as Laplace inverse of, we have called this one capital F of S, and we have called this one capital G of S. So this will give us F convoluted with G as per the definition of convolution theorem. So because we know by definition, F convoluted with G this is T, is given by the integral 0 to T F T minus V times G of V dV. So this will be integral from 0 to t. Now, f of t is given by e raised power minus 2t. So this implies if you are asked to find f of t minus v, be given by e raised power minus 2 into t minus v. And this implies g of v will be given by e raised power minus 3 v. So using those values, we'll get e raised power minus 2 into t minus v times e raised power minus 3v, then dv. Now, this will give us f convoluted with g integral from 0 to t. Now, this is the same as e raised power minus 2t times e raised power minus is plus, so 2v times e raised power minus 3v dv. So which can be written as integral from 0 to t e raised power loss of indices minus 2t plus 2v plus minus 3v will be minus 3v and then dv. So 2v minus 3v will give us minus v. So this is the same as f convoluted with g integral from 0 to t e raised power minus 2t times e raised power minus v dv. Because remember, these were the same as minus 2t minus v, so it's the same as this one, loss of indices. So because we are integrating with respect to v, then e raised power minus 2t is just a constant, so this is the same as e raised power minus 2t integral 0 to t, and then e raised power minus v dv. Now integrating this will get minus e raised power minus 2t, and then e raised power minus v from 0, v to t. So it will be negative e raised power minus 2t. So I put t, I get e raised power minus t. I put v for 0, I get 1. So on multiplying, we'll get e raised power minus 2t, and then minus e raised power loss of interest minus 2t plus minus t will be minus 3t. So therefore, this is the convolution of f and g, which give the required result, because they are the same as L inverse of capital F of S times G of S. So this answer to the first part. Our second question, part B, we had, so B, we were given 3 over S into S squared plus 4. So the trick is to see that this can be written as 3 over S times 1 over S squared plus 4. So we let capital F of S be this first, which will be 3 over S, and this second one be capital G of S, which is 1 over S squared plus 4. So which implies that the question inverse Laplace transform of 3 over s into s squared plus 4 is the same thing as saying inverse Laplace transform of f of s times g of s, which by definition is f star g as a convolution. Now, when capital F of s is 3 over s, this implies, using tables of Laplace transform, then f of t is 3. And then g of s given by 1 over s squared plus 4 implies g of t, using tables of Laplace transform, will be a half sine of 2t. So this chapter assumes that you know how to deal with inverse Laplace transforms of some elementary functions given in the Laplace transform table. So this implies that the inverse Laplace transform of f times g will be given by f star g, which by definition is integral from 0 to t f of t minus v times g of v times dt times dv. This is by definition of what we call convolution of f and g. So now f of t is 3 implies f of t minus v is still 3, so this is a constant function. And g of t equals to a half sine of 2t implies g of v will be a half sine of 2v. So just replace into this function, you get that convolution of f and g will be integral from 0 to t of 3 times a half sine of 2v dv. Now 3 times a half is 3 over 2, so we can factor it out. 3 over 2 integral 0 to t of sine of 2v dv. And when you integrate sine of 2v, you get negative. So we have 3 over 2 into, so this will have now cosine of 2v divided by 2, and then v from 0 to v equals to t. And so when you multiply, so when you put in v, so we'll have lower limits will be negative 3 over 2. When you put in upper limits, we'll have cosine of 2t over 2. Lower limit now, when you put v or 0, we'll have cos of 0 is 1. 1 over 2 is a half, so minus a half. Now, minus 3 over 2 times minus a half will give us positive 3 over 4. So we'll have positive 3 over 4. And then minus 2 by 2 is 4, so 3 over 4. And then cosine of 2t. So it can just be written as 3 over 4 into 1 minus cosine of 2t. So this becomes the answer to the convolution of f and g, which defines the answer to the given problem. Thank you.